What is the shape of the Earth? You could see this by viewing Earth. Earth is really big, so you're gonna have to get far away, but then you could see Earth. That's one way. You could physically measure Earth. You could just go all the way around Earth and measure the change in the height, and then you could, map out what the shape of the Earth is. Or you can see how objects appear far away and get closer. If you're on a flat surface, objects that are far away are going to be smaller and then get bigger. That is not the case. We do not see that. We see the top of objects rise up, and then we'll see the bottom of the object. That right there show that the Earth is not flat. Just from the appearance of other objects from far away coming to you, it proves that it's not flat. You can either be flat or not in nature. So it is not flat, it is curved. The other way that represents this really well is the sun on the horizon. It rises up. Okay, let's just say that we know that there's some sort of rotation or revolution going on. Okay, so when you see the sun, the Earth was flat, which you already proved that you've seen objects are not smaller to get bigger. But if the Earth was flat, wherever you see the sun, you would just go wherever you saw the sun at the horizon, and you would see the edge, because that would have to be. You would have to see as soon as the sun is available, stops getting blocked by Earth, it's on the flat surface, you're going to see it right away. And so you could traveling there, and you don't see an edge, so the Earth doesn't have an edge. You were looking at Earth's curve was blocking the sun. So you just proved that the Earth cannot be flat right there with two reasons. Does the Earth revolve around the sun? If you take a picture of the sun every single day, at the same time, you're gonna see an infinity sign get traced out in the sky. That's because you were revolving around the sun. And because the sun rises like above the horizon and then below, that is because the Earth is rotating. So if you're revolving around the sun, that's the proof right there. So the sun can't be revolving around you, so therefore you have to be the one that's rotating, that's causing the sun to do this. So that would be right there. Those four reasons. You have what is the shape of the Earth? And then, does the Earth rotate and revolve? And then the fourth reason, the fourth thing is, why do we not get flung off of the equator? The Earth is rotating. You know how the rate of the Earth is, right? What's the rate of the Earth? You should be able to know this. What does it spin? 24 hours, 360 degrees. So if I could spin my arm or my hand 360 degrees in 24 hours, I'd go really slow. Earth is going so slow. Now the Earth is big, so you're far away from the equator, so you're traveling a lot of distance. The Earth only curves 8 inches per every mile, so you're only dropping 2.2 feet per second by my calculations. I can post that later. And so there's not a lot of change that you are experiencing. So you can actually measure this. You go to the equator, you will weigh 0.5% less if you're at the North Pole. Or if you were at Mount Everest, you're going to also weigh less as well, because you're farther away from the surface. So this is measurable. So it's just, it's not a lot. So the Earth is not spinning fast enough for you to feel like any big change. So that's why you're not getting flung off the Earth. What's the shape of the Earth, and does the Earth rotate and revolve around the sun? All of this is enough evidence that you need just by observing the sun and a couple other logical constructions, experiments, and you know what the shape of the Earth is. It's not flat. It's curved. I'm putting the evidence out there. If there's any way that this fails, please let me know. Please post about this. But this is all you need to know to feel completely confident that the Earth is not flat. It is curved. It is round. It does rotate, and it does revolve around the sun. There you go.